Hey, my. 3.2 problems. Let's let it ride. This ready is all about solving linear systems by graphing. Well, what exactly is a linear system? Let's take a gander. Systems, we've actually seen a quick sample of this in the previous Desmos lab where we had, that one table with all of the values with the height of the water. So recall we had that one table. And then what was the other thing that they had? They had the table, and I think they also had a graph. Correct me if I'm wrong. But either way, a system is pretty much two or more equations graphed out on the same graph or used in the same story. And so what we're doing here is really just graphing those out and seeing where they go, where they intersect. Seems simple enough, doesn't it? So we are given this first, what we call a system, where we have f of x equals 2x minus 7, g of x equals negative 4x plus 5. So let me color coordinate here, count them. We have one equation and we have a second equation. I try to color coordinate, but it changes up. Yeah, so notice we have two equations and we're really just graphing them out on the same plane. That's it. And hopefully they intersect. Maybe they won't, but let's do this thing. All right, so this is definitely in slope intercept form. So I know based off of looking at this, my slope is 2 and my y-intercept is -7. So we can hop right into this and start graphing this out immediately. So I'm finding on the y-axis where we hit -7, which is here. And I know that my slope is 2, so I can go over 1 and then up 2 to get another point on the line. And then I could keep this going if I wanted to, but I'm pretty content with just having this as is. So once you have your y-intercept graphed out, once you have your slope mapped out with it, just graph it out. We've done this before, okay? So then we can take care of the second equation, which I'll show in blue. So g of x is gonna have a slope of 2. Psych, is it? Well, what's really the slope? What's the slope for g of x? What do you think? Hopefully you're saying -4. So -4. And then what's our y-intercept? What do you think? I got 5 on it. So this means that I have a y-intercept of 5. I can take a look at my slope. I know that's -4, but if I wanted to write it as a fraction, I could use -4/1. So I know what my rise and my run is. You're more than welcome to do this if your slope doesn't look as if it's a fraction. So I know that I can go rise -4 and then run 1. And that would get me the other point here, which is 1, 1. Okay, cool. So we see that if we were to continue this and graph out this line, as soon as we are able to do it, wouldn't be that line. So we would have our starting point of the y-intercept, and then we really just take it through that other point. Seems simple, right? So I know that this is gonna all right, sorry for the delay. We have the second line graphed out. And so if we look closely at where these intersect, where does it look as if they intersect? What's this point right here where they intersect? Well, let's see. This is 2 in the x direction, and then it is down 1, 2, 3 in the y direction. So we would say that our point of intersection is 2, -3. Does that make sense? Does it make sense how we did it? Because really, we're just doing the same thing for these other ones. To help you out with the others, if you want to take a stab at 3, For f of x, you could say that your slope is -1/1 and your y-intercept's -2. For f of x, you could say that g of x's slope is -1/1, and that for f of x, the slope is 1/1. And for over here, although it looks as if we don't have anything added on as our y-intercept for f of x, what could we say is really being added on? Hopefully you're saying 0. So that should help you graph these out. Hope that helps. For the set, we're taking a look at the attributes of a function based on graphical representation. We've talked a little bit about in 3.1 where it was increasing with the pool, when it was decreasing with the pool, or constant, if there was a minimum or a maximum. So I'll take care of this problem 7 for you. So I'm going to highlight, let's see, how can I do this? I'm going to highlight in pink where we're seeing the interval increasing. So I know that this from here to here is increasing. And I know this because it's going up and to the right. So I can say that for where it's increasing, this occurs from -10 all the way to this coordinate here, which is -9, -8, -7. So from -10 to 7. And since we want to include those terms, we'll use brackets. Don't forget that. We see that we also have some increasing here. And this is from -6. Because again, this is the x coordinate here, -6, up to our x coordinate here, which is -2. So we're just trying to size this thing up and say, all right, where is it increasing? We also see some increasing here from 7 to 12. So count them. We have 3 intervals where this is increasing. Does that make sense? Pause the video, actually try this out. See if you can get a hold of where it's decreasing. So pause the video, see if you can get a hold of where it's decreasing. So hopefully you were saying that it was decreasing from this x coordinate here, which was -13, all the way to here, -10, and we can include, so we use brackets for that. In red, this was definitely decreasing from -2 all the way to 5. And I'm using brackets to denote that. Do we have anywhere where it's constant, where it looks like a flat line? What do you think? Hopefully you're saying none. There's no place on this graph where it is constant. Let's look and see where we have any minimums. I'm going to highlight this in, let's do orange. So I see that here, this would be considered a minimum because it's at the bottom, like, of the scenario. Well, let's actually look for the minimum of like the whole function. That's the minimum between those 2 intervals, but the minimum of the whole function, what do you think? Where's the lowest y value for the whole function? Hopefully you're saying here and here, because this is the lowest y value that's used. So you could say that you have minimums, and I'll just cut this down to mins. We have a minimum at 5.1 and also at -6.1. And I'm using parentheses here because I'm talking about these as if it's an ordered pair. So I'm not using interval notation here. I'm saying that at this point, we have the minimum. I hope that helps. So what do you think about the maximum? Pause the video, try it out. Hopefully you were saying that you had a max at -7.8, all right? So this can now tie into the domain and range. If you need the information that's here, please take it. I'm gonna be deleting a little bit to talk about the domain. So recall, the domain deals with the x values that we have set up in this function, all right? So I don't think this can, I think it's tough, but I don't think it's too tough. So you just really have to look closely on what x values you're using. So I know that we have our function going from here to here as far as the x values go. And this would be from -13 to -7. So again, I'm talking about my domain. So I know from -13 to -7, I'm using all of those x values. But notice, I don't have anything between -7 and -6. So I would actually say that there's a union, and I'm using this U to say there's a union, like we're uniting that with the domain that we continue to use from here to here, which would be from -6 to 5. Does that make sense? Can you let me know if you have a question? Please do so. And then I'm going to continue this domain because I see it's going to go from here to here, and it's hitting everything in between. And that's kind of what I'm doing with these little post marks or these kind of field goals, because hopefully it's good. I'm highlighting on where the function actually is, and I don't care about where it isn't. All right, so this is +7 for the x term. Notice that there's a gap between 5 and 7, which is fine. And then this picks up back again and keeps going all the way to 12. So that's my domain. And I'm using brackets because I want to include everything that's there. So I hope that helps. What do you think for the range? Do you want to try this out real quick? Pause the video, try it, get the range, see if you can do it. All right, we're back with it. Your range should have been from 1 to 4 because of this little triangle here or pyramid. Lowest y value is 1, then it hops all the way up to 4. And then we see that there's a gap. So we don't want to include the interval between 4 and 5, but we do want to pick up back again where it goes from 5 to 8. So that's why our range is from 1 to 4 with brackets in union from 5 to 8 with brackets. I hope that helps for that one. We're then going for the explicit and recursive down here. We've seen these quite a bit. So let's hop into it. Switch this to purple. I know that our starting point always is mentioned in the recursive. So I'm saying my starting point is 5. And then how do you think this is continuing? Well, we see that every time we move forward, we're deducting 3. So let's give respect to that. Let's just say that f of x, our function, equals f of x minus 1 minus 3. And if we wanted to use a sentence, we could type something like this, that we're starting at 5, we deduct 3 x times, okay? And so that's actually going to help us with the explicit. And actually, since we're on the end term for 5, we'll say it's x minus 1 times. So this sentence actually is going to help us make the explicit, which is going to be starting at 5. So let's write this in. Starting at 5, we deduct 3 x minus 1 times. And that should, let's call it n minus 1 times. And that's equal to f of n. So let me actually change this so that it says n minus 1. There we go. And so we would start, this is from module 1. So truthfully, this should be just a quick refresher, something that you just need a reminder of. But it's all good. How about this? Try 11 and 12, and I'll give you the answers for those shortly. So pause the video, try 11 and 12. All right, I know I said that you should have been trying 11 and 12. I did 11 for you though. I said that this was multiplying by 2 because every time it keeps multiplying the previous by 2. So with the recursive, we're stating that we're starting at 6 and we just multiply the previous by 2. Again, f of n minus 1 is just talking about the previous term. So that's why we're using it here, because we're trying to relate it to the function now. For the explicit, I made this sentence, and I think it's helpful. You should do it too. Start at 6, multiply by 2, and since this is at n equals 1, we have to give respect to that and say that it occurs n minus 1 times. So that's why n minus 1 here is my exponent. For 12, I'll walk you through this because this was a little challenging. So I know that the jump from -13 to -5 is going to be adding 8. But look closely. What's the jump for our n terms? Hopefully you're saying that that's adding 2. Okay? So that's saying that, well, if we assume it's linear, we may have a slope of 8 over 2. But let's try it with the next term. So -5 to -1 would add 4. 2 to 3 would add 1. So it should be clear that our slope here is just going to be 4. And I think that this was really important to look at closely because your n values here weren't just going by ones. Right here, it goes by 2. So you got to give respect to that. So this can actually help us put together our explicit because we're starting at -13 and we add 4 n times. And so we can call that f of n for the explicit. For the recursive, they give us f of 0, which is definitely -13. And then how do you think we can write out the rest? Hopefully you're saying f of n -1 just plus 4 would get you there. And if you wanted to, you could fill in what the n or the first term is when n is 1. You could just, add 4 from here to here, take it to -9. I hope that helps. The sentence is pivotal. This last part should have felt like a review. If you have any questions, holler, let me know.